Hello, my name's Max, and I'm going to talk to you about ellipsoidal lattice structures. So the best place to begin is really where this work started, and it started from cylindrical lattices, and they have lots of interesting properties and applications. So the similar thing that Cressida was talking about, they can go through large deformation, they are highly tailorable, they have nonlinear stiffness, and they have many more properties, but those are the ones that I'm interested in. And it's those properties that make them useful for a wide variety of applications, such as a quadrifilar antenna, or robotic actuator, which Cressida was just discussing. But where my project differs is that I try to release that constraint that these are cylindrical structures and try and see if we can use these in alternative geometries, and then by doing that, can we get some additional exploitable behavior? And the geometry that I've chosen to look at the moment is to go for ellipsoids rather than cylinders. And we've done that to see if we can get some more applications from the properties that we'll get from these structures. So some of the potential applications I see are capturing containment from the enclosed volume. We have flow regulating nozzles from the variable aperture. We can get spherical antennas from the adaptive geometry, and we can also use them for springs/energy harvesters for the tailorable stiffness. So where's my project been going? What have I been doing? Well, I've spent most of my time modeling these ellipsoidal lattice structures, and there's three stages basically. So first of all, there's a manufacture stage where I can include pre-curvature of the structure of the individual beams, and this can be the same for the cylindrical lattices. Then I have the assembly stage, which differs from the cylindrical lattices, whereby I can induce my ellipsoidal curve, or whether I want to extend that into other shapes of cones, hyperboloids, paraboloids, and all of that sort of stuff. Now, when it goes into the final stage, which is the operation, this is where it becomes interesting, and we get some of these additional behaviors that I was talking about. We have shape adaptation between this static shape and some of these additional forms that the structure can take. So looking at the far right-hand side, you can see that the structure's got new enclosed volume that you don't have with cylindrical lattices, and we're going to be looking further at how we can exploit those. And while doing that, some of the ongoing work is I'm going to be generating a general model for lattices of arbitrary shape, see if we can tailor the energy landscape, characterize the dynamic response, and then build some experimental demonstrators so we can see physically what these things do. Thank you. Do you have any questions?